Here we are in our second page, and I really like this example because it forces you to create your own production possibility curve. So suppose an economy produces only two goods. We know this is a very simplistic example, but this is how we begin to develop a more sophisticated version. Baseball bats and 2x4s. Also, the only input, right? We have one raw good that becomes either of those finished goods, right? So we're just putting in lumber or trees. Basically, one tree makes 10 baseball bats, okay? Or you can make 20 of the 2x4s, right? So if I have one, right, and there are 5 trees in my economy, okay? So I have 5 trees and I decided to make all baseball bats. Okay, what would that happen? Well, one tree makes 10 bats, so I can make, if all the trees are baseball, I'll make 50 bats, right? If, however, I choose to use all 5 trees for 2x4s, right? We have 5 trees, and every tree, right? One tree makes 20 2x4s. So I'd make 100 2x4s. Okay, so those are my options if I go all one way or all the other way. So let's take a look. So plot one point labeled A on the curve that represents 40 bats and 20 2x4s. Well, 1 minute, we're not there yet. Okay, let's just start for bats. What's the most amount of bats I can make? I make 50 bats. So my biggest number here is 50 bats. That's the start of my curve. Or I can make 100 2x4s. Okay, so my curve will somehow, we're probably going to need some points there to make that accurate, will somehow range from, right, between there. Now I'm going to need a point on there that's 40 bats and 20 2x4s. So let's divide this area into 5. That's about right. So 20, 40, 60, 80, 100. And let's divide this. 50 can go into tens, right? So 10, 20, 30, 40. Okay, and we want to label a point that's 40 bats and 20 2x4s. So 20 2x4s and 40 bats. Let's put that point there. And this is going to be, okay, point A. Okay, and then we want label point B that represents 20 bats, so 20 bats, and 60 2x4s. This is our point B. Okay, then describe the total opportunity cost. What did you have to give up from point A to point B? Okay, so what we gave up. So we went from point A to point B, we went down in bats. We lost 20 bats, so opportunity cost was 20 bats, right? And we gained, okay, 40, right, from here to here, we gained 40 2x4s. But opportunity cost is what we gave up. So we gave up 20 bats. So that's the answer there. Okay. For the example above, if the firm is producing at point B, what is the opportunity cost of making one more bat? Okay. So let's take a look. What's the change? What do we give up? Well, here, that's what we need, that kind of slope. So when we lost 20 bats, we made up for it by 40, right? So 20 bats, losing 20 bats gives us 40 2x4s. And we could see that even from the initial part, that we always make, right, 10 baseball bats gives us 20 2x4s, right? So it's kind of you can make twice the number of 2x4s for every bat, twice the number of 2x4s for every bat. So what's our do? So we're making one more bat. If we make one more bat, so we add one bat, we're giving up 2 of our 2x4s, right? There's a 1-to-2 ratio here. What are at least 2 elements that can cause the frontier to shift outward? Well, we discussed this on the other side. Like, what if I could take this point and move it this way? Like, why wouldn't I be able to do that? Make 40 bats, but now make also 40 2x4s. Well, we could change the quality of the good, right? We could make somehow 2x4s with mulch or something else. But we need to somehow, right, or to even shift this outward, we'd need to, so this would be A prime, because it's different, or B prime. So 2 elements that shifted outward would be a change in technology, so improved technology, right? So maybe I could have a better cutter that could cut, more bats, right? We can reduce waste, right? If you think about a tree, right? If we're cutting a big tree stump, and we're trying to make bats out of it, maybe I could go all the way out. Maybe I could use that extra resource on the outside. Okay, we could improve the skill. Okay, and to shift inward, what would happen is maybe we could make fewer. Right, we'd go to right. We'd have to shift inward would be to shift in here or to come in there. Right, so we'd have a double prime or a triple prime even. Okay, or bring B further in. So B double prime. Okay, the way we would do that is we're making less of each thing. Less of each thing would mean that we would improve quality, or we'd have to increase waste, or like stuff that's not productive material. Maybe we would reduce the amount of raw goods we have, like how much. Let's say the trees, let's say we got new trees and the outside was totally not usable, right? So then we'd have less tree to work with if we kind of look at it like that. So these are just concepts that are a more generalizable way to do it.